So I was going to start with, before I even introduce myself, some audience participation. To be kind, this is my first time, as was mentioned earlier. So I want to ask, how many people have used or do the library, the Scala library Cats, the Typelevel Cats library? About half? That's pretty much exactly what I was hoping for. That's good. And how many people know what a type class is, or how to use one, or how to write one? About the same. Cool. So maybe this is only relevant for half of you, but the other half can give me horrible questions at the end. So the Cats library, this is what you'll see if you go on their website. Yeah, words. But for me, it's a big grab bag of functionality you can add to your existing library, to your types, to anything you want to do. There is probably some use you'll find in Cats. So when I joined, I'm Monty. I'm a software developer at Over Energy. Got one Over Energy person in the room. When I joined, I was a Java developer, joining a Scala team, a very highly functional Scala team, already using Cats, already using a lot of sort of deep Scala stuff. I found I quite quickly got to grips with using Cats, but never really understood what was going on behind the scenes. And in writing my first talk, I wanted to create a talk that would have helped me when I first started using Cats and functional Scala in general. So I asked my peers what their experience was with Scala, if it was the same experience I had, and I was met with a lot of, we don't use Scala, we don't use Cats, which was quite surprising to me. I found it quite essential, and I think a lot of functional programmers do. There were some valid concerns, but had a lot of, it's too complex, it's unnecessary, we don't need monads. And so the other part of this talk will be hopefully demystifying Cats and hopefully showing it's useful outside of that sort of category theory scope as well, and that you can use it in any project and it's not difficult to use, it's not complex really. So I think that association with functional programming and category theory is something that sort of scares people away from Cats. But I think also the patterns it uses are quite unfamiliar, especially if you've come from a more object-oriented background like Java or Ruby. And I think that's something that also scares people away. We're going to be focusing there today. So with that in mind, this is what the talk's going to be about. We're not going to talk about category theory at all, which I'm sure is good for everyone here. We're not going to mention monads, monoids, functors, anything like that. We're definitely not going to talk about effect types, nothing category theory in the talk. But we will be talking about polymorphism, adding functionality to things. We're going to be talking about type classes, the main pattern that Cats uses to do this, and obviously that involves some implicit stuff. So I apologise if this is all very familiar to everyone, but we'll go through it anyway. So this talk's going to focus on, firstly, subtype polymorphism, classic sort of OOP approach to functionality stuff. And we're going to move from that, we're going to show that briefly, and then we're going to change it to ad-hoc polymorphism using type classes. And we're going to do this all in the scope of sorting a list of something, in this case ints, but your humble sort function. So should be familiar ground for most people. Okay, so, and it's all going to be live coding as well, so definitely set myself up for failure in my first talk, but wish me luck. Okay, so hopefully everyone can see that. Is that big enough?
Yeah.
Cool. First of all, 5 points for whoever can name the sort. Just yell it out. Can you name the sort, just as a intro? Over there first. So I've got this sort. It just sorts ints. Kind of useful. But I've got this new class that I want to use in a list, say, person class, and I've defined this myself. So how do I sort persons? Obviously, we could just define like a sort function for persons, but they wouldn't be useful for anything else. So as we're all good programmers, we want to be more generic. We want to be able to apply this sort function to an A type. So this is going to look something like this. And I'm actually not going to try and remember quick sort on the fly. I'm just going to copy paste. So done, right? Finished, great. So not quite. we don't know how to compare A's together. We don't have this less than operation. We don't have anything like that. The compiler doesn't know what an A is. It can't infer that. So how would we approach this in a sort of subtype polymorphism way? Well, first thing we do is we would add an interface. So I'm going to add a trait, and I'm going to call it orderable. And the intention of this trait is to be a supertype of whatever we want to order. So in this case, it's going to be A's, but we'll add it to the person class. And what it needs to be able to do is compare to another instance of A. So I'm going to call that. And if you remember your compare syntax, it returns an int, and the int goes something like this. This bit I'm going to definitely screw up. So if this is less than other, then this is negative. If this is equal to other, this is going to be 0. And then obviously, if this is greater than other, this is going to be positive. Okay. I'm also going to add a quick helper, because we saw it just there. We're going to add a less than function as well. That's just going to return a boolean. And that's going to just use our compare function. And that's okay. So that should be familiar. This is pretty much how the comparable interface in Java works. If you're a Java programmer, I'm sure there are similar ones. So how do we use this in our sort? We introduce a type bound for our A. And spell orderable right. And we import orderable. And remember that, yeah. And that should compile. So now, anything that is orderable can be sorted by this function. So we have to make our person class orderable, and we do that by extending and implementing. Okay. My commands here. There we go. Let's actually put the right thing in there. So we have a choice to make here about how we sort persons. I'm just going to choose age because it's the easiest one to use. But it's noteworthy that we have to make a choice. Like we have to define the way we want to order persons and put it onto the actual class. So in this case, it's going to be this dot age minus other dot age. So if this age is bigger, then this will be negative, and that works out if you think about it. So the other thing to note here is that we use this. This is how we compare two things. We have access to our current, and then we have another one passed into this function. Okay, so let's actually use this. Let's hope this all compiles. So I'm going to run. So I've pre-prepared a list of persons here. There it is. I'm in the way over here, sorry. And now I can call my sort function with this list, and it should sort them. Cool, job done. So the problem here is that I also have an int list. And say I want to sort that, and I want to use my generic sort because I only want to maintain one function. And obviously I can't do that. Like it's not implementing my interface. And if I pass it in, it'll give me a big error. So that's not great. And we can't go and fix this. We can't go into the int class of Scala/Java and add this orderable trait and implement it. We don't really have any options here. We can't order ints. The other thing is if we want to change the sort of persons, if we want to sort by name, for example, or if we want to reverse the sort, we have to actually go into our implementation of person and change that comparison function, which is annoying to have to go all the way down into our actual class that's just holding data and change something. So what can we do about it? And this is where I'm going to introduce type class and ad-hoc polymorphism. So I'm just going to delete all that. Okay. So let's go all the way back to when we had this. We had this sort of failed generic sort with nothing on it. So I'm going to reintroduce the orderable trait with some slight differences. Okay, still going to take a touch for a second. So instead of just taking one other of whatever A I'm trying to compare, it's going to take two. It's going to take both in. So it's going to look something like this. I'm going to have a left and a right, and that's going to return an int, the same as last time. I will not write that comment again, that took too long. And I'm also going to put the less than on the just for our sort function. This is going to return a boolean, and we're going to use our compare function. So very similar to last time, this time we pass in both parameters. The intention here that this won't be implemented by our person class, so we won't have access to this, so we have to pass them both in. So how are we going to use this in our sort function? So our A is not going to be A orderable anymore. We're not going to get that for free from our A. So the only option we really have is to pass this in explicitly. So we're going to need some instance of this class in order to use it. And we're going to pass it in a separate parameter list. And also, we don't get this nice syntax anymore. We're going to have to do something like this, which is a bit clunky. And copy that. So this is now going off the page. And also, this isn't, let's call the actual function. And it's still not compiling because I have two parameter lists now, so I need to pass through this order instance each time as well. So this is getting worse and worse, really. Okay. But we have a sort, it's compiling. So the next stage is to somehow create this orderable instance for person. This isn't going to be a super type of person. In fact, we don't need to change the person class at all. You just need somewhere else where you put an instance of this thing. A common place you'll see such instances is on the companion object of person, and this will be relevant later when we start introducing implicits. So I'm just going to put it there for now, and I'll explain why later. I'm just going to put it in a val. I'm going to call it person orderable. Right, and now we just need to implement this interface. So we're going to do the same as we did last time. We're going to use age, so it's going to be left age minus right age. Okay. So now, hopefully this all compiles, and we're able to go back to our shell and do exactly what we did last time. Okay, so we have our person list. There it is. And hopefully we should be able to do what we did last time and sort persons, but we need to pass in this instance. So it's a bit clunky. I call it person orderable. So there we go. That sorts nicely. So we've got the sort. We've removed the subtyping part, but we've changed like the call site signature. It's a bit clunky now. We have to remember where these things are. We still can't sort ints. Like we got no sort of. Not only can we don't have an instance. What do we put here? For example, for the ints, we don't have an instance. So this is the same, but potentially worse. Like we've got a clunkier call site. We've definitely added like some nastiness to the syntax of our actual sort function, and we've had to, it's not great, is it? So can we address this and still unlock some new, some goodness out of it? So the first thing I want to address is this call site problem. How can we get around passing this thing explicitly? And that's the clue, I suppose. So I'm going to introduce some implicits here. So in our sort function, I'm going to make this second parameter list implicit. And this does two things for us. This allows us to pass in, allows for the orderable instance to be passed in implicitly, so from implicit scope, wherever you're calling this from. It also means it's added to the implicit scope of this function. So we no longer need this second parameter list here, and everything will still compile. And in order to make these orderable instances available in implicit scope, we can make them implicit where they're defined. So we can make this val implicit. And because of implicit magic, this all works, right? Don't worry, I will explain. So if we run this again, we'll see that we can just sort persons exactly like we do with the subtype polymorphism, with no extra additions to the call, like that. So the reason this works is one of the places it will look for implicits when it's trying to find one is on the companion object of the A of the class that's parameterized on the function. So that's one problem out of the way. We've got the call site back to subtype polymorphism, and we're probably like equal now in interfaces in terms of whoever's using this. So is there any advantage of this approach? Well, the first one is that we can use our generic sort for ints now. Even though we don't own the int class, we can define an instance. We didn't have to change person, so we can now do the same for int. Obviously, because we don't own the int class, we can't add the companion object of int. So one place you'll commonly see this is if you do own the type class itself. You'll see this on the companion object of the type class. And again, we're going to make it implicit. And so I'm just around. Okay. And right. So this is nice and easy, this one. And one as well. Okay. So this tiny bit of code will allow us to go back to our shell and sort ints exactly like we did with persons, which we couldn't do before with subtype polymorphism. We'd have to write some kind of wrapper around ints, and then so if I show you my int list and then call, just put it at the top. And the reason this works is because somewhere else it will look for implicit resolution when you call this function is on the companion object of the type class of that implicit parameter list. Cool. So where have we got to? Oh, okay. It's worth noting that if you don't own the type class itself, you don't own this trait, then you can't obviously add it to the companion object of the trait. So occasionally you will see something like this, where you have to define an instance for something you don't own with a type class that also you don't own. And sometimes you'll see this in an instances package with a companion object. I just thought I'd quickly show that. So new companion object, package object, there you go. And you'll see it in here, so something like, should have copy and pasted. Okay. And we can still do the same thing we did before, but there's a slight gotcha here. I'll just quickly show it. So we've still got our int list, and now if we call our sort function, everything should work. Everything implicit magic, right? So no. And the reason is we haven't imported this instance package, so we don't have this nice sort of, it's on the companion object, it automatically found by the implicit resolution. So all we need to do is import this instances package. And this is a common pattern you'll see, that's why I'm showing it. And now that will sort. So cool. So now we can use our generic sort function that we've defined with the type class that we've defined for a type that we haven't defined and that we don't know. So slightly more functionality there over subtype polymorph. Okay. So just take a pause. And does everything make sense so far? Are there any questions just about this bit? Is everyone just following along absolutely fine? Fantastic. Look at that. So what we've done here is something that's quite common in functional programming generally, which is we've taken a concept such as subtype polymorphism and we've turned it into a value. And the benefit we gain from that is a higher level of abstraction. We can now take these values and we can compose them, we can transform them, and we can create new values. And that can unlock quite a nice level of abstraction, as I said, and also reduce some of this boilerplate. We can get some nice functionality out of it. So the first one I want to talk about is, what if we want to reverse the order of any of these? So in our orderable trait, hang on just a second, catch up with myself. Probably the next one. Nice. Okay. So, what if we want to reverse an order? How can we go about that? Does this approach do this better than subtype polymorphism? So, what we can do is we can take in an orderable instance and we can in a function and we can transform it and turn it out the other side, and we can do that to provide some kind of reverse functionality. So if I define this function, and it's going to take in some orderable, it's going to take it in implicitly as well, and it's going to spit out an orderable as well. And this is surprisingly easy to define. We have this orderable for A already, so we just need to compare them in the opposite order. So this will take a sort and reverse that sort, give us back an instance that has the reverse sort of the one we passed in, implicitly. So how can we use this? We don't need to make any changes anywhere else. If we go back to a shell, so our person list. So if I sort the normal way as defined on the person's instance, we get this way. And now I can do two different ways of actually applying this reverse. I can do, so because the sort function still has this sort of second parameter list, even though it's implicit, we can pass in our orderable instance explicitly. If I do person list and then, so this is me passing it in explicitly. Now what's happening here is that this reverse function itself finds the initial person orderable and spits out another one that's explicitly passed in. So there's implicit resolution here, but not at the sort function level, at the orderable reverse, if I spell orderable right. And that's reverse the order. The other way we can do reverse is in this scope, we can override that implicit. So if we define an implicit value here, reverse, let's call it that, give it the type, and the implicit, the type inference in Scala will be clever enough to know that I want the reverse of a person is just by this, just by the type parameter on the actual value. And now if I call just normal sort persons, it will have the reverse sort. Not quite. Oh, sorry about that. Hmm? Okay. Oh yeah, okay. Okay, I'll skip that for now. But you can do that. I've obviously just forgotten how to. So, something else we can do is we can take away this. So, a slight problem here is that this boilerplate's annoying, right? This whole like creating a new instance every time. What we can do instead of that is take an orderable instance of something we know how to order, and then transform it to something we don't know how to order yet. So how about something like this? So I'll explain the signature in a second. Okay. And let me just, there you go. Okay, so we know how to order Bs. We have an instance for this orderable B, and we have a function that takes us from the thing we want to be able to order to that B. And again, this is pretty easy to implement. We take our orderable instance for B, and we apply a function to each A that we passed in. I hope this makes sense to everyone. And what this allows us to do is reduce a lot of boilerplate and also make our code very readable. So if we go back to our person class, we know how to order ints. We've seen the instance already. So now I'm able just to call orderable dot by, and this takes a function. So I'm going to take a person, and I'm going to pull off the age parameter, and that can pass because we know how to sort ints. That's available on the orderable companion object in the implicit scope. And now we're just saying we want to order persons by age, and we already know how to sort ints, so we don't need to redefine that. And also if you use a bit more Scala sugar here, this becomes really readable, right? We're saying orderable by age. So it's very good. If we then go back and we add an implicit, an instance for string, use the Java, or whatever Scala does. Then we can change this sort in the implicit scope as we saw before. Hopefully I won't get it right this time. So let's scroll to it. So hopefully hopefully now I'll be able to demonstrate how you can change the sort on the fly. Again, start with a person list. So if we want to sort by name, just in this scope, just for this bit, we have like a default sort that does by age that we've defined in the person class, but instead we want to sort by name for some reason. And all we do is we define an orderable instance in this scope, add it to the implicit scope, and this will take precedence over the one on the companion object. And we can use our nice new syntax as well for this. And now, that's be good. Now it sorts by name rather than by age. So we are able to change the way we use these type classes, or choose the implementation in the scope that we want to call it on, which again we won't be able to do with subtype polymorphism. We can change these things on the fly. Sort may not be the best example here, because I don't know why you really want to change the sort that often, but this can be very useful. And it's extra functionality of a subtype polymorphism. Okay. So the last problem we have is that our sort function itself, I mean it's off the page here, but it's quite clunky. We've got this second parameter list, we've got this horrible syntax here with order. Is there anything we can do about this? Can we make this nicer to use, these type classes? And yes, the good news there is that we can. So the first thing I'll address is the syntax. What you'll sometimes see is a syntax package. No? Excuse me. Okay. And that will have a package object. And we're going to use an implicit class. I think this sort of pattern has a name. I think it's one of those things about Scala that draws people in from something like Java. I think it's called the pin my library pattern or something similar. But we're going to use an implicit class, and this will wrap any instance of A that we have an orderable instance for, and allow us to add functions to the end of it. So we unlock that nice syntax we saw before. So we're going to call this orderable syntax, if I can spell. And this is going to wrap a value A, if I put the type parameter, but only if we have an orderable instance for that A. Okay. And the function we want is this less than. Now this sort of looks like our original sort of subtype polymorphism where we just have an other and a this, except that this is passed in sort of explicitly and is the sort of the class wraps around it. So we can do we have our order instance and we just pass these things in, nice and simple. Okay, so now if we go back to our sort and we remember to import this, so it looks something like that. Now we can use this nice syntax. So this will look something like this. This will look exactly like it did before. Just to demonstrate this, you don't want to see that. So it's actually there. Like you can obviously IntelliJ will do this for you, but there's nothing fancy going on. This is just now available on this function. And do it here as well. Nice. This is starting to look a bit more like what we had before. This nice sort of like use of these type classes you can get back to the stage where it feels a lot like you're using subtype polymorphism and the niceties you have there. So the other thing we can do is we can get rid of this second parameter list. There is some Scala sugar that allows you to do this, and it's called a context bound. And again, it looks a bit like a type bound. There's no arrow there, and we're not passing. There's no like type parameter. But what this will do is this will find an orderable instance for A and add it to the implicit scope. What it won't do is give you explicit value to call. So for example, I mean, it seems pretty obvious, but we don't have an order anymore. That doesn't exist. Luckily, we don't need it because we're not calling that explicitly. But there will be times which you need the instance to do something with. And to get around this and to keep this nice sugar, we can add what's called a summoner. So this is going to look like this. What's it going to do? So if we have I'm not going to explain this too much, but you'll see this on a lot of type classes, so just know that it's available to you. Now what this allows us to do is pull it out of implicit scope into a value. And the syntax of that looks like that. Quite simple. And now if we wanted to, we could go back to our old horrible syntax, which looks like that. And that's all fine, that all compiles. Okay, so we've managed to get this to look, if I just read this quickly, a lot like what we had before. With this nice syntax that we're all sort of familiar with and happy with. I mean, this is pretty readable. All we had to add was this context bound. For the person itself that we want to sort, we had to add just this sort of couple lines of code separate to the class. We didn't actually change the class at all. What we did have to do a lot of, though, is a lot of this stuff. Like there's quite a lot of code gone into this type class. So in our actual sort of application code, nothing's changed too much. But we haven't actually changed like our class, and we haven't changed our sort too much. So it'd be great if we could get rid of all this like boilerplate. We wouldn't have to define this ourselves, so we just delete it. Just delete it. And we'll delete this as well, we don't need that. Obviously these imports aren't going to work now. So what if we still want to sort persons? What can we do? We want to still use type classes and stuff. Well, that's where cats comes in. So cats version of my order rule there is called order. So if I change this, import cats.order. This here. And now I don't have this nice syntax, but again, cats provides, so syntax order. Now that looks exactly the same. And this is actually a tiny bit of code, right? We've got two imports and a context bound, and we can do this sort of generic sorting. For person, obviously this is a similar problem. We don't have our order anymore. We need to import it, so cats.order. Now I should have saved that, shouldn't I? That. And this isn't compiling because we don't have the order instance for age, but again, cats gives you a lot of instances for free. We go into the instances package, look for int, now that'll compile. And so what we've done here is very little work, right? We've added a couple of imports, context bound, out of the person instance to implicit scope, a couple of imports, and we've done a generic sort. And we've done it all without having to change our person class. So our person class can be somewhere complete. And we don't have to change that. We can do this for types we don't own. Obviously we don't own the order type class itself. Cats owns that. So we can add this functionality anywhere. I just want to quickly show this, or explain what this has actually done for us. Ooh. Too far. Okay. So what we can do here is we've added functionality to the person object without changing it at all. So we're now able to compare persons. Obviously, this is quite a powerful approach. We could go on forever doing this. We could add loads of functionality to classes without ever needing to change them, without them ever needing to be anything but just value classes or just simple data classes. And more than that, just a quick taste of the sort of power you can get to without any extra work. Say we want to incorporate the name into the sort, but we don't want to stop using age as well. So what we can do here, we have this return a tuple instead. Indulge me for a second. So what that'll do is now it will sort by age, and if they're the same, it will sort by name. Again, very minimal code for what's quite a lot of functionality that we didn't have to define ourselves. We've added, again, 3 lines of code. And another nice thing about cats, which I think a lot of people really enjoy, is that if you can't remember where all these instances and syntax things are, there is just this magic import you can do, cats implicits, and it just makes everything compile. So even if you don't take anything about where the syntax and the instances live, just use that, just use cats implicit. And that, yeah, that's basically the talk. I mean, I've ended up with 5 extra lines of code from where I started, so very slow live code session, but unlocked quite a lot of functionality.
Did you find that declaring the implicit instead of the single impact the performance of the compiler?
Yes, yeah. So adding this cats implicit import is expensive for your compiler. You will find your compile times are slower. So it is good to remember where all those things are. But if you're really struggling, cats implicits can help. And especially when you get quite deep into all this stuff. Occasionally you'll find no hit and it just makes everything work, makes everything clear. Okay, well that's the end of the live coding portion. We'll just go back and summarize where we got to. Oh, the slide, all this code is on, I mean, there's nothing there now, but you can go through the commits and see it if you want to go through it yourself at that link. So, over subtype polymorphism, this sort of ad hoc polymorphism with type classes, we can add functionality to types we don't own, which can be very useful. We can change that functionality in different scopes. So if we want to have a different sort function, if we want to have a different way of doing it to string, is one similar one, then we can do that in different scopes. We gain a high level abstraction. We're able to compose these instances, create new instances on the fly very easily. This just is high levels of abstraction are what we're about. Makes them more applicable as well. And I think the big thing here is it enables libraries like cats. Cats library just adds functionality to types. It doesn't own that's exactly what it does. That's not possible with subtype polymorphism, obviously. You'd have to go through and implement everything. And what if you want to do this for like Java time instant or something? Cats library would be useless. So this pattern enables stuff like cats, which I think a lot of people find very useful. And yeah, as we all like, it allows others to do your work for you. So that's good. That's the end of the talk. I have a few links that I think are useful. There's the actual cats library microsite and their blog, Typelevel's blog on type classes. And a few good talks as well. Petra at Scala Days did a talk on polymorphism. There's no live coding, so you won't have to live through that, but it's a really extensive view at polymorphism in Scala. And it also looks at how type classes will look in Dotty and New Scala, which is quite a bit different. It formalizes a lot of these seeming hacks that we have here. And also, mainly because I absolutely love this talk, but it does explore further into type classes. Rob Norris's Scala X keynote. Lots of pretty pictures of stars, but also it goes into like type class laws, how do you ensure that your sorts are doing what you think they're doing, and etc. And it's just a great talk. I just suggest that to anyone.